Now there are a couple questions that I will show you that you can do yourself. These are very easy questions. If you have doubts, you send me on WhatsApp, but send me the picture of this also, because I might not remember which question we are talking about. Very easy question. The same thing, whatever is the change in mass is the conversion of energy. Phase 4 test. Okay, I'll figure that out. Okay, I'll see what is the syllabus for phase test. I will say tell you in the next class. Okay, so there are no secrets to success. It is the result of preparation, hard work, and learning from failure. So obviously that's so right. Okay, anybody wants to stay, you can stay. Otherwise, I'll see you in the next session now. Anybody wants to stay, please stay for next 15 minutes for relativity. So very quickly, so good night everybody who's leaving. Very quickly, in 2 minutes, we started with two postulates. I don't have much time. 11:15 we are going to end the class. I have a limit because I wake up at 5:30 in the morning and I don't get any sleep in between. Okay. Now, two postulates were, number one is in inertial frame of reference, all the results of any scientific experiment will be same. So you cannot tell whether you're moving or you're not moving. You cannot tell. You cannot prove basically, right? Secondly, C is absolute number. Okay, it's not relative. When you watch the speed of light, you're going to observe 3 times 10 to the power 8 in vacuum. No matter if you're moving, if the source of light is moving. Based on these postulates, some things come up. And I'm not going to any derivations. Derivations are very simple, but we don't have time for that. Number one was relativity of time. The time dilates. So time dilates when you start moving, the time slows down. What happens now is this. So let's say, don't look at the expression there, we'll talk about it. Very ugly diagram. Let's say you are riding a spaceship, but you'll be inside. Let's say you're in the spaceship and you're traveling. What happens? The time slows down. Maybe you have a watch. The watch is going to slow down. You will not realize. It's not like you will see the time has dilated, because you will not even realize that. For you, the watch is still doing tick, 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 because your mental clock, your biological clock, all the neurosystem inside you has slowed down. You don't realize the things are going slow now. The plan that you have in your aircraft, it is going to slow down the growth. So if it was supposed to grow in such a time, it is going to slow down. The clock of the flower has also slowed down. Something, let's say you take dahi, the curd, and it spoils in one day. For you, as per your clock, that dahi is also going to go bad in one day itself. Everything is going to slow down. You will not even realize. Who will realize is the person who is not moving. Let's say this person had some way to figure that out. He will see that your clock has slowed down. He will say that you look at your tick tick tick, it is very slow. So when he goes through 2 seconds tick tick, you go through only 1 second of tick 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 maybe. Okay? So only this person will realize that. And this expression relates all of that. So I'm going to explain this properly. T naught is the proper time interval measured between two events when the observer is at rest with respect to the events. Event kya hai? Let's say we are talking of, no, we are not going. You see, Ninad, that is the point. You're really trying to jump a lot of steps in there. So Ninad is saying, is it possible to do future traveling and all that? We are not talking about it. We are at the very initial level of understanding it. If I try to jump, it is already complicated. It will complicate more than that. Okay. So now you're time traveling anyways. When you take a train ride, you're time traveling. I'll tell you why. You're already traveling in time. No, please listen here. If you're going to distract like this, we are not going to cover anything. Okay. So now let's talk about the clock that this person has. This person's clock, the spaceship person's clock. He's looking at the time in this watch. The event is time is 11 sharp. The event is it is 1 second past of that. So this person looks at the event. For him, the event is happening at the same place. Because see, after 1 second, maybe the person is here. है ना? So for him, the event has happened at the same place. For him, the event is happening right in front of my eye after 1 second also. The event happens at the same place. This time is called the proper time. Proper time is for a person who is watching the event happening at the same place. Now, dilated time. This person looks at event one happening here, event two happening here at two different places. He will see the dilated time. Dilated time means slowed down time. He will see the dilated time given by this expression. So you got to plug in the velocity of the spacecraft here and the velocity of speed of light. You can see it is not much difference if you're talking of the train journey or if you're talking of the jet plane journey. It doesn't really matter. But it really matters if this plane was moving with 2 times 10 to the power 8. 2.5 times 10 to the power 8. It really matters now. So what you will see in the numerical that is coming up on the next slide, you will see that it really matters. And this person, the blue person, will say, oh, I can see the clock of that person going very slow, because when my clock says 2 seconds, it is only saying 1 second. What happens now is the red person is aging half the speed now. So when this person, the blue person, grows old by 10 years, red person has grown old by 5 years. The plant in that spaceship has grown old by 5 years. Everything will slow down. The red person will not even realize anything. Is that clear? Now, the same argument can be made from the red person's perspective also. If the red person is watching the blue clock here, from the blue clock's perspective, the blue person is watching the correct time, the appropriate time. So when he sees 1 second here, the red person will say, oh, the blue person is actually slowing down less. He's aging less now. Because the red person looks at this watch and sees the dilated time. Red person says, I am looking at the perfect time, but then the blue person is aging less. And this is one of the paradoxes that we see, the twin paradox and all that, right? If this slide is clear, anything related to this slide only I'm going to honor. Ninad, any question related to this slide only, nothing more than this. It is already very complicated. I'm now going to jump ahead. So let's see who all are in this class right now. So I have Abhinaya, Ninad, Sai Kumar, Shivangi, Shreya Bhatt, and Vasudeva. Any questions based on this slide and only this slide? Okay, Ninad knows this part. No, more complex things I cannot cover. You really have to stay with me for 5 hours at least, for not even 5, 6 or 7 hours. Based on my past experience teaching relativity, at least 6 or 7 hours is needed to be like a fully expert, I would say. Okay, Vasudeva doesn't have any doubts. I'm going to move on here. So very quick question and numerical here. Just read it. I'm going to explain that. And I'll grab a calculator maybe. Yeah, I think I will need a calculator for this. So let me grab that. And I don't think we can cover a lot anyways because time is running fast. It's not dilated in my watch. Okay. So what happens here is, what we are saying is, there is a watch here and this jet plane is going with 0.92 c, like 92% with the speed of light. So when 1 second has passed there, what does this girl see? This girl will see the dilated time, which is 1 second divided by square root of 1 minus 0.9 c divided by c whole square. ठीक है, तो कितना आ गया 1 डिवाइडेड बाय 1 माइनस 0.9 का स्क्वायर कितना आ गया 0.81। ठीक है ना, मैंने कुछ गलती तो नहीं की इधर, करिए। ओ 92 है ना, वो 92 है, अच्छा ठीक है 92 है, तो 0.08 है ना, ये आ गया 0.08 आ गया इधर। ठीक है, सो दैट कम्स आउट टू बी 1 बाय रूट ऑफ 0.92। नहीं क्या कर रहा हूँ मैं यार, नहीं 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 नहीं, सॉरी सॉरी, माय बैड, I'm really stressful, I'm looking at the watch here. So 0.9 का स्क्वायर करना है ना हमको, 0.8 आ गया ना वो, तो 0.81 आ गया, 0.92 का स्क्वायर करो, 0.92 टाइम्स 0.92, दैट इज 0.8464। ठीक है, ये आ गया। अब 1 में से माइनस करो, 1 माइनस 0.8464, That comes out to be 1 by root of 0.1536. So that comes out to be, let's say, where is the square root of here? 0.1536 आ गया 0.39. So 1 divided by 0.39, something like that. So that basically converts to 2.5 seconds. Very ugly calculation, I agree with that. But in a nutshell, when this person says it's 1 second for me, this person says no, 2.5 seconds has gone by now. ठीक है? Is that clear? ठीक है. So very quickly, this thing. I mean, I don't really have time. I think I should take a 1 hour class on this. Let's skip that. ठीक है. Length contraction. Of length में क्या? I'll just explain this and end the class. Length में क्या? ये पेन है. ठीक है. You can take a scale and measure this. Okay, 1 centimeter, 2 centimeter, 3 centimeter, whatever centimeters, maybe 10 centimeters long. Now I give it to you. You say 10 centimeters. इतना होता है, right? I look at it 10 centimeter. It's absolute number. Right, you might say this is small or big, that is like relative thing, but when we are talking of centimeters, it has to be 10 centimeters. It doesn't, there is no relativity there, right? Its length is not relative. That's what it looks like. It's absolute number, but that is not right. The length contraction also happens. कैसे होता है वो देखते हैं. Let's say this is a person and this person is here. ठीक है. Now there was a jet plane here. Now jet plane is traveling. तो बिकॉज द जेट प्लेन इज ट्रेवलिंग, ये जो पर्सन है ये बोलेगा इसकी लेंथ अगर जब खड़ा था, ये जब दिस वाज जस्ट स्टैंडिंग हियर, द लेंथ वाज एल नॉट. इसकी लेंथ अब पता है कितनी हो जाएगी? इसकी लेंथ हो जाएगी एल नॉट डिवाइडेड बाय, सॉरी, एल नॉट मल्टीप्लाइड बाय द लॉरेंस फैक्टर. Length is contracted. This person will say the spaceship is actually tiny in the direction of travel. No other dimension changes. It is squeezed in the direction of travel. He will look at it as a small thing. Now look from the jet plane's point of view, it will actually say the distance has squeezed now. I will actually draw another picture here. Let's say jet plane was stationary. ठीक है? Jet plane will see this is the earth and this is another planet here. As soon as it travels here, it will say this length has contracted. ये short हो गया, and these things are closer now. The faster it goes, the contraction is more and more. Because you can look at the Lorentz factor here. More the velocity, more the shrinking in the direction of the travel. Everything else remains the same. Other two dimensions remain the same. Only the flattening part happens in the direction of travel. तो ये person कहेगा कि this one is squeezed, but this will say this length has contracted. This has become smaller now. Things have come closer and closer. And I think this is actually making more confusions there. So I don't know. Because I'm trying to squeeze everything in 15 minutes. No, this topic is nowhere. It's nowhere. It's just because Ninad says I wanted to, Ninad wanted to study, that's all. It's not in curriculum in any of the Indian syllabus. Forget it. It's not even there. Okay. Many more things will happen. I think I'll just show you the slides. I mean, I wish I had more time. I could have done that. Relativistic momentum. Momentum is not mass times velocity. That is what Newton says. This is Newtonian momentum, right? Actually, the momentum is mv divided by this. But do you really care? This number is so tiny. It's very close to 1, all this, right? In the Newton's world, you say mv, but then the things are moving fast, like electrons, you cannot use mv as the momentum. Momentum is this. Many more strange things happen. Look at the energy now. Energy is not mc squared, and what we were studying so far. Energy is this. Many strange things happen. Simultaneity, something that you will study later when you actually go into details of this. Simultaneity. This is the last thing I'll cover. Simultaneity is यहाँ दो light bulbs हैं, right? I simultaneously switch them off together. मेरे पास special powers हैं. I can switch them off together. ठीक है, एक ही स्विच है, मे बी एक ही स्विच से दोनों ऑफ हो गए, राइट? सो आई विल से दीज आर साइमल्टेनियसली टर्न्ड ऑफ. Ninad will say simultaneously turned off. Abhinaya will say simultaneously turned off. But that is not a fact that you will see if you start traveling. So let's say there is a light bulb here. I don't know how to draw a light bulb. And then there another light bulb here. Okay. Now if you're traveling, you're running very very fast, or in a jet plane, you will say ये on हुआ और फिर ये on हुआ, या फिर ये off हुआ और फिर ये off हुआ after some time. It is not simultaneous. So even simultaneity is relative. When I'm standing here, I say these happened simultaneously. These two events are not simultaneous when you're running.